Bryce. So you are Ryan, right?
Yes, sir.
Starter. Bryce, Austin.
Okay.
Oh no. Kenny, Austin, and then another Ryan. Ryan number 1.
Oh, what the heck? Maybe you Ryan
Ryan
wants
number-
it. I love it.
And then
That's the first name.
I get the Ryan. That's what I like it. Ryan number 1.
and then Kevin.
Okay, that's me.
Okay, my name is Iwan. Iwan Sanjaya. My last name is hard to pronounce, so I go with the first name Iwan. Nice and simple. Dr. Freud tells me a lot. I guess like my name in Chinese means 10,000. So that's Iwan. Means 10,000. Do you want to know anything about me?
How long have you been in the United States?
8 years.
What did you do?
Mostly in Texas. Yeah. I should introduce myself. Like, my name is Iwan. I am from Alcoholic Anonymous, Texas chapter.
And you were at Baylor, right?
Yes. That's my wife. She is recording the lecture because Dr. Iris want to know like how I teach for the first time. Yeah, her name is Meta. Our home is 7008 University Boulevard. So if you want to come by,
On
it's near
campus.
on campus.
Is that the one right
Between
across from
nursery
the,
and preschool.
campground right there?
Yes.
Yeah,
yes.
okay.
Big
Yeah.
I saw Don Martin's car there and I was like, I bet that's.
Yeah. So you can come by and yeah, hang out. Definitely not drinking, right?
No, none of that.
Our parents are here.
But we can have hot tea or hot chocolate.
Ah, hot chocolate. It's almost winter time.
Yeah, apple cider and that kind of stuff. Ginger ale. Anything else you want to know? Do you want to introduce yourself? Like, give one thing that interesting that can, like, if we talk about it, will last like, more than 1 hour. Something that's interesting about you.
Ryan should start.
I was the driver of the award-winning EV Grand Prix car.
A great basis
I
for yours.
am the world's greatest solderer.
No.
Oh, yeah.
The dean likes to embellish. I helped design the EV cart with Ryan, and it took a long time, but we made it win. Is that what made it take so long? I crashed the EV cart
There you go.
into a giant pole when Dr. McPherson asked me to go max speed on a sidewalk that was not fully cleared of people, and I lost control when we were changing the steering
And
mechanism.
what was at the base of the pole that you hit?
Concrete,
Yeah.
solid concrete, which destroyed the frame, and then I spent several long hours with Larry in the engineering center just fixing it, and it was brutal. But we did it, and we won. So I mean, really, can we even complain? We got first place. Come on.
Yeah, no, we can play.
We'll make the new version.
Yeah,
That is
we'll make the new one. It'll be great.
Nice.
Now
I
without
don't know about my name's Ryan. I'm the Ryan.
We'll talk about
We'll see. Fun. What a fact. Oh man. I like Dominion. I have like 4 expansions on Dominion. It's a card game, great game. If you haven't heard of it, you should try it out.
Okay.
The deck building game, it's really fun.
I'm Bryce.
Hi, Brian.
Bryce.
So, fun fact.
You just broke up with your girlfriend, didn't you?
No. I play guitar. I do a lot of worship stuff. I'm gonna be helping Dr. McPherson tomorrow. Worship parking chapel. So it's pretty cool.
I'm Kenny. It's like Ryan, but spelled differently. And
What? I used to call him Ryan constantly.
yeah, yeah, that's the whole point. Let's see. I'm working with Dr. McPherson to develop his mechatronics robot. Yeah, really? Yeah. Okay. And no, yeah, I mean, it's just another pay out of the class or the job, but you know. Yeah. Let's try to see this.
What's it like at Valparaiso?
It's like here, but real sad.
What makes it so sad?
Welcome, I'm also new.
Fair enough.
Okay, today we will discuss pulse width modulation, PWM. But I would like to review first, like what we learned last week. So today's talk is PWM. Review. Because when you watch TV serial, you always have like previous week, right?
Previously on.
It's the same. Like, so last Monday, right? Last Monday, yep, we discussed about analog output, right? Analog output, and then we try to generate analog output. First, we generate like just the voltage, right? Like the voltage voltmeter here, right? Generate the voltage, and then after you generate the voltage, then if you do it over time, you will have like sawtooth, like this one, right? Yep. Or triangle, right? This is so. Or sine, right? Because it's analog, right? So that's what we learned. And now we try to generate the same thing but with digital output. So we already have digital output, and then now how to make it into analog, right? Digital to analog, because digital is because our word like the microprocessor word is digital word, so it's easier to generate digital signal. So that's the first point. So from digital, right, to analog. And then the second point is we can use it for what is the application that we can use for that one? Like for DC motor, right? I saw in engineering center today there is someone with the small robot, right? DC motor with gearbox 18:2, the ratio, right? So you can drive DC motor with PWM, and then for dimmer, do you know dimmer? So when you have light, right, light bulb, right, and then it can goes up and down, right? And there is some sliding switch, right, that can arrange the brightness. So you can use that one also, or you can use another thing is for the when you have curtain, right, and then you have lamp, and then you can create the dimmer also as the sun goes out, and then this one goes bright, right? The lamp goes bright. So that's the dimmer application, and then servo is similar with DC motor, but this one is I can move it into specific angle, right? At my undergraduate, we use it for the spider robot. So you have like several servo, and then create the leg of the robot, right, for every joint. So that's the servo robot, the servo motor. And then many other things we will discuss later at the end. I will give you another example. Another way to see it, but yeah, I will go back to that idea later. And then why we use it, because MWeb has many more PWM port than analog port. because analog is expensive. Okay, and then I will start. There is in the core glass board. There is someone who write this one. Write this code. Great majority of people have more than average number of like. I don't know who write it. You write it?
I did not, but
Oh, okay.
it's funny.
And then I'm a little bit confused, right? And then I have to use my computer engineering skill to explain, right? So I try to draw, because I love visualization, right? So I will draw something here. Okay. And let's see. Okay. So imagine this one is the number of legs, right? 2 for people, right? And this one 0, right? And then what is the average? So in here, I mentioned the average will be like here, right? Really small, right? In here, right in the middle, right? Because this one is like 50-50, right? And in here, because this one is, we have more people with 2 legs than 0 legs, then we will have it like here, right? Okay. So this one is the average. Okay. So that makes sense, right? So I think this code is more on the third case, right? Because majority of people is 2 legs and some of them like 0 legs or less, or maybe there is a bug here, but still with 3 legs or more, it would be weird.
Yep.
But still the statement holds, right? Okay. But this one is also, if I change this one not into legs, but into 3.3, right? Volt, right? This one is Pulse Width Modulation. So I try to take the average of the pulse, right? So frequency modulation, I try to take the average, and then when I get the average, so I will have DC. So this one is DC, right? Like the voltmeter, right? The volt source, right? Voltage source, right? And then I should put in here should be the period, and in here should be period when the signal is on, right? Okay. And then we have duty cycle. The cycle is T on over T times 100%. That's easy, right? And then because we care about only for the value, how we can take the average. For LED, you can supply directly. You can try it later. So you can use this one. So it's like the LED will on and off, but because it's so quick, your eyes will see it's always on, but with less brightness. But for other things like if you want to generate like really DC voltage instead of signal, right? So you have to use low pass filter. Do you remember this one? Low pass filter is with R, and we have C here, capacitor, right? And this one fade in. This one is V out, and V in I will put the signals. I think you have it for electric circuit, remember? Because if there is capacitor here, then what would happen? There is the cycle of charge and discharge, right? And then if you have it in very high frequency, so you will have something like charge, and then going this one and discharge going this one, right? Charge and then discharge and so on, right? But if you have it in very high frequency, you will have only the top. So it's like a ripple, but like this one, right? Like a sawtooth, but it's, this one is, for example, 2.54. This one is 0, right? So because it's really charged and then discharged, and charged because like the cycle here, the period is shorter, right? So it will have like this kind of effect. So you will have upper and lower voltage as voltage, but still there is some little bit ripple. But yeah, that's I mean we can tolerate in some application. Okay, that's good enough because you cannot square the circle, right? If you have circle, you can square it. Even in Fourier, you can do it. Okay, that's one, and this is number one, and number two. Number two, we can drive it as resistor and coil here. What is this? Inductor, right? Inductor and RL, right? RL. So this one is motor, right? You can replace it with motor, right? Because motor is basically is a coil, right? But because it's coil, it's also have resistance, so resistance and coil, right? And inductor. And then in here we use the diode. What we call this one?
Like a flyback or something.
Yeah,
freewheeling.
Diode. This one is resistor. This one is inductor. And in here I will have the signal. So that's the two things that we have to make it happen. And later you can try, for example, for this one, you can try. I will give R for 1 kilo ohm, and C is 0.1 microfarad. Sorry, millifarad. With frequency for 90 hertz or around 500 hertz. You can play around with the frequency also to see the effect from this signal to another signal. Okay, and now how to use it is actually pretty easy. So we just need PWM out. Okay, this one is I will create PWM object for specific pin. Okay. And then you can write. Write is output duty cycle, right? Between 0 to 1, right? Or I can use also the sign equal sign, right? So I can use this one, the sign equal sign. That's we call it event defined operator. Okay. And then I can read, because I can write, I can read. I can know the current setting. Of PWM. And then I can have the period. I can set the period. This one PWM period. I can do it in. I can put it underscore millisecond or underscore microsecond. And then I can have pulse width instead of defining the duty cycle, right? I can defining, if I don't want to define the duty cycle, I can just use pulse width. And similar in millisecond, you can put underscore millisecond and underscore microsecond, or can you just put the floating points there. That's the similar. Okay. Okay, next thing, you can try to program and then connect to the internet, connect to the oscilloscope and see the pulse. So duty cycle, so write is setting up duty cycle, right? T on over T, right? That means this part over the whole things here, right? Or you can specify the period and the pulse width here. Yeah, this is another application of pulse width modulation. You just replace the LED with the infrared and then become the remote control. The first program should be that one is the second one. I think the first one is the first one should be really simple. So PWM out, and then the name of the object, right? And then the pin, right? That's the first one. So I create the PWM object and assign it to pin G9, and then I set the period and using the operator equal sign, right? Or you can use write also. PWM dot write, that works also, but this one is much more simpler, right? The duty cycle is 50%. And then take the probe and then try to connect it to the D9 and see what happens. the Macmillan always play music, I will play music also. This is my children's song.
Put on piezo. What a guy. Thank you. No problem. Sorry about it.
Dude, you know what, just for that, there is a point system, and you just pass the point.
Ooh, for half a week.
Break fresh stuff every game.
Points for what?
Life, they're called life points.
Okay, you guys clip right on.
I think it's Kenny's opinion.
It's like, yeah, it's literally my affection for you based on how many points you got. And Caleb just brought us.
Just high score wins, not golf, right?
Yeah, high score wins, yes.
I was
Just
just
around.
thinking that.
Honestly,
What's wrong with Dr. McFerrin's music?
I'm not in middle school anymore.
I really hope he watches
I
this.
hope you. I hope you watch this. Dr. McFerrin, I love you, mate. I love you. Never even watched that. Yes.
Are you not connected? Did you actually push your
He just-
file?
He just got to watch me do the report for a while.
Are you sure you did D9?
Oh,
I said D9.
Or you probably could.
there it is. See 50% duty cycle. Once it figures out what it is.
You said D.
That's just high. You sure did that right? Show us your code. Oh, really? You type your
I don't know about that, but.
This is 5 seconds per division. You're an animal for doing this. You know what? All else fails, just press on it right. So what's your time step? Your cycle's 10 milliseconds. Yeah, does that pin even do pulse width modulation?
Yeah, it does.
Oh, no, that's good.
It'll be breaking stuff back there.
Apparently. It's nanoseconds, keep going out, right, you did milliseconds, it's microseconds per division.
Look at that.
Thinks it's a small signal. Maybe I'm not actually touching the mesh. Pretty sure I touched the mesh. Are you on ground? Yeah, you are. Come on, wait, it's no problem. We can, I want 5, I want like 10 milliseconds per division. Oh, you're not grounded, are you? Right. Oh, I see. No weights.
Oh, because I can't.
That's you or PM that you
I'm trying to find my
That's also.
Oh, also I can't go to Pulse tonight. So I think after softball, we'll go out there and grab some races.
Yeah.
That'd be pro, because there'll be somebody there.
For sure you, I have to go out.
That was that fly. So when, oh, after softball.
After the rehearsal.
Oh, after rehearsal.
I'd like to go out.
Brian, does yours work?
What?
Like, yes.
Does your otoscope thing work?
Come on, computer. computer engineers, am I right?
Dude, I
Yeah,
know
it's
right.
Oh my goodness.
It's at Bryce defaulting to hardware issues.
It is a hardware issue.
Did you not just, you know how to copy, you know how to look at it?
Yeah.
I see exact same thing.
It was simple.
Get rid of your while. I don't need a while.
Oh my god.
Watch this. Watch this.
Did you? Better.
Oh,
No,
really?
I-
You think it's not going to constantly reassign it?
Oh, I should
I do say 50%. Golly, gee willikers. Oh, you made me so mad I want to fly to Antarctica and shoot a penguin.
I will put it in the oscilloscope also, the one that I sell it.
What? Yeah, you just zoom out and
Really? Every time it loops, it would set it high, and then like, alrighty, now I just need to wait a few, like I just need to wait 5 milliseconds. And you know what would happen? It would say, alright, now I just need to wait 5 more milliseconds. It would set it to high again.
Work holder, you're losing a lot of points. That's all I'm saying.
I feel like the participation drill is great, right?
No, I don't believe in that kind of stuff.
Darn.
Maybe.
What do you think at the top of the EV card code, all the pulse width modulation setting stuff is up at the very, very top, outside of any loops or any conditionals? That's not true, they're in some if statements. We should have another look at that code.
I just code was like just.
I still love you.
Where is that? Is that on GitHub?
Yeah, it's on GitHub. Anybody can look at it.
I was gonna say, I think I
No,
know.
false. Private.
Access for something.
It's a private repo, anyone in the engineering department can create it. That's true.
This is like.
Brought us to the doctor.
That's what I feel, that is why. Why?
Get the coding skills?
Yes, because that car would drive itself.
Dude, we wouldn't at least be dealing with this whole Verizon issue right now.
You shut
Maybe
that one back
maybe
on?
we could add, we don't have a SIM card activated because they lapsed on whatever. And we had to go and pull SIM cards out of all the critical points.
Can you see it?
Yeah, it's on the screen. I see pulses. I no longer see pulses. There. So that signals the song, but it's sending the piezo?
Yes.
That's nice. Remember the last time I operated PWM?
Oh, we almost.
Oh yeah, assembly language. Oh.
Yeah.
Good times.
You know, dark interference is not the only tech. It's pretty good tech.
The next one is, the next program is, let's see. Hold on. So I will try to increase so I add index I, right? And then I set the period, right? But for the duty cycle, it depends on the I, right? And start from 0, and I keep incrementing by 1%, right? And then it will last for 0.2 seconds, right? And then it will change to the next one, right? To the higher. So starting with low, all low, right? 0% means all low, right? For 0.2 second, and then a little bit high, right? 1% of high, and then 2% of high, 3%, and so on until like it's all high, right?
And then when it's all high, will it roll over and reset, or will it
And then we'll reset because this one is while, right? While loop, right? So after this one finish, it will goes back to I equals 0 again and
Yeah.
0 again.
So our duty cycle is gonna go from like 0%
Right.
all the way up to 100%,
And then 0
back to 0.
What, are you gonna put that? Or you asking?
I'm not any. I'm not going into it. So let's be careful.
Maybe he's not a fan.
I like plus equals, I have that in my code. Bert, you get 1.5. One.
You're on thin ice up here, Bert. I really don't know why.
Now, Bert Holder, I mean, you guys both have a lot of points. Like, you guys are both up in like the hundreds of points on.
How sweet.
Yeah, Ryan has 12.
Where am I?
See, look, there it goes.
You have 99. What?
Can you slow it down?
What did I do?
Make the weight.
Just like when you threw up in our room.
Oh.
I like to be able to appreciate it.
Did we gain anything from these points?
Where did that
I love an effect. What did
Our
you
work
get?
is more digital or more analog?
In what context? Currently, it's very digital.
Currently it's very digital. Right? It's going to digitalize everything, right? Like even books and so on. But it used to be like more like analog, right?
What should you wait for?
You lost a lot.
I always like the examples of photocopy machine. Photocopy machine, right? That's analog, right?
Yeah.
And then like, but printer is more digital. So that's why if you scan and print, then the result will be more exact, right? Because when you copy something analog, something lost there.
Yeah.
But you have to remember also our DNA. What? Is digital also, right? But having 4 instead of 2, right? 4 states instead of just 0 and 1, right?
There you go.
So that's why when DNA replication, it's better, right? Because imagine if the process is analog, will be like you are like copying and copying and become degenerate every offspring, right? Every
Yeah.
succession.
best player in baseball is? Bert knows the answer to this question.
Just no. Best player in baseball. Should I fish?
Who?
The fish?
Mike Trout.
Oh, yeah. That's his nickname.
Done?
I think ours is working.
It's working?
I don't
Yeah,
know.
getting bigger and then flat.
And then
Okay.
starts small and gets bigger again. So there's zeros work?
Hey, why don't you back off?
Okay. You just don't want to talk, and I just don't really understand why.
It will stuck in your head.
It will be. What kind of music do you listen to, Dr. Sanjoya?
To be honest, I'm not really into the music, so every music sounds beautiful to me. Because whenever I sing, like my friend says, are you singing or reading? So I enjoy every kind of music.
You like Dr. McFerrin's music?
The last one is really good.
The Martian?
Yeah, The Martian.
That's a good movie. The Martian's actually a movie, the soundtrack's really
You should just play Jonas Brothers voice.
Do you-
Dr.
McFerrin's
Have you
gonna
seen
watch
their set
that.
list for their tour? All the songs they have to choose from? They have some good ones on like Year 3000.
And then
Why are we talking?
I love it.
you can try using the RC, right? This one. Put the R and see the. There is some guideline in instructables, but for the Arduino, but it works also for the same thing. But you can calculate, for example, if you use R equals 1K and C equals 100 micro, and then so the voltage is around 2.5, and then you can see in 2.5 if you zoom, and then you will have peak to peak people voltage, right? So peak to peak people voltage is this one, right? So you can have the people there, and then measure how much is the people.
What are you grabbing, Brian? Okay, yeah, what micro developer? What do you want to grab?
You can use 1 kilo and 100 micro. Kilo.
That was just the close. Actually. Price should also like one.
I would.
Or also grab a LED and then just put the LED there, like right now. Just put LED between the output. So you can use LED also. So this one is bring in. Just put it to ground. Something like this one.
You still see this mu?
What?
A millimeter?
Yeah.
Who did you organize this? Didn't you?
What do you need? I'm looking for.
Except things have been happening.
I'm just gonna grab 100. Yeah, okay. I think my brain aneurysm has stopped. I think this is the right one.
Also,
It is.
LEDs or diodes, why are they not the diode section?
PWM,
That's your call.
What?
Yeah.
Oh, yeah, mixed up it.
And then light emitting lights.
No, they're not here with 7 seconds.
Oh, of course, that makes much more sense. I haven't been looking at it since. What's the V card?
Just try this one first, because this one is easier. Just plug the LED to the output and the ground, and see is it the brightness change or not. So
We need a safety resistor. Probably fine. Dude, what do you think ground is? I mean, you could have just gone in one.
yeah, you should put
They already did all of them, I think. We can probably put some on order.
See, Ryan, now I wish I would have taken that lady you tried to hand me. Because this right here, it's broken.
Nice.
Price? I can see when I do something at 0, but after that, it looks like it's always on.
yeah.
It wavers a little bit, and the brightness,
Yeah.
it bright, the first. Stop it, someone needs to help me.
You will see that one better with the light bulb. If you put the light bulb, it will be
Probably slow down steps. I can't go faster. There is no fly back here. What are you doing? We're making a low pass filter. No, that's good. I didn't give you an inductor.
So there's drilling.
Resistor from B
You know what?
to
I'm working on it.
nothing.
What's wrong?
Put it in backwards. I mean, what is this, engineering 2000? I didn't tell you which one's the cathode?
Yeah, no, it was in the right. You know how this works, cable?
You haven't grounded it then.
Yeah, it's grounded.
It's blown.
Is the.
The LEDs are such simple components. Is it really not
No,
working?
not crazy here.
Alright, I'll come take a peek. You got an infrared LED.
These aren't blue, these aren't.
Oh yeah, you can't see that with your naked eye. Yeah, just throw that wherever.
I mean,
Thank you so much.
you're right.
This is
I was thinking it's a clear white light.
No,
That's why.
This, I think this is
Yeah, that's
infrared. I'm fairly certain.
Are they?
Is that why we had the little
You
time?
sure?
Yeah, dude.
100% sure?
The clear ones?
Yeah.
Yeah, they're infrared.
Oh, I thought we had like white ones, because I have white in the kit that I bought.
Or we do have white ones that are mixed in with infrared ones. I don't know.
I think we do. I got some bad news. Hey, Ron.
What up?
Hey, those are infrared back there, but I'm pretty sure we also have white. Which means you have to sort of what those are, dude.
Dude,
No, I'm pretty sure we
I
got
just-
toss one of them back into full clear.
Oh, this is gonna be fun.
Actually pretty simple. Just takes it all money.
It gives me work hours.
Yeah, sure, you're running on a
You
lot
get
of
$8.
hours.
Yeah.
Hey, how long do you think?
Hey, dude, look at that ripple. Look at that ripple.
We're meeting with her to discuss her partner. Downstairs.
What are you measuring? You're measuring this thing.
Yeah, I haven't changed.
That's where her lab is, like.
You haven't even built the low pass.
Yeah,
Build it. Alright, I will build the low pass.
She's,
filter.
her office on second floor.
Is that alright?
Her lab is. Oh, yeah. That's nice, right?
Another examples of PWM is when you see train, right? When you have train, and then usually between one, what do you call it? I know in Indonesia, but I'm sorry, I'm stuck.
Train track? He's talking about carts.
Yeah, like between train carts.
Train car, yeah.
There is like a small slit, right?
Yeah.
And then, but it's moving so fast, right? So if you stay in front of this one, and then you seeing through, and then you can see the whole background, even though it's like it's only one slit moving, right? So it's similar idea with the LED one. That's why it become dimmer, right? Same idea. And another cool, I talked with Dr. McMillan, like you can have a final project instead of final exam. For example, if you don't like to do that, like memorizing, I don't like memorizing things. I like to try things and using it more practical ways, right? So if you have like more that kind of tendency, so you can ask him for the final project. One of the idea is this one. Maybe you see it before.
I have seen this before, actually. It's pretty cool. I have one of these in my computer at home. It's got all that stuff.
So it's a motor with LED, and the LED drive with PW pulse, right? And then you can have clock, right?
Very cool.
Another idea is like, instead of doing it with motor, just make a long stick, right? With many LED, and then with some accelerometer to know the position, right? And then you can wave it, and then you can use it in football, for example. Right? Asking free t-shirt, for example. Or you can use spin top, right? Like in the movie, and then in the surface of the spin top you can put something like that. Just another idea, another application of PWM. I think that's the better one.
That looks really cool. You know, if we increase the frequency, the capacitor will have enough time to discharge.
That looks like fun.
Very nice.
It's up.
Alrighty.
Oh, yeah.
Okay, Okay, so time's up.
That's class.
And then I always ask feedback for my class, so you always can leave feedback like what is a good point, what is good analogy, what good is illustration, what is the muddiest point that you don't understand. You can ask anything, and you can leave it in. I think I have it here. Say. Well, I use my watch in there. Oh, not working.
So what? Why you guys say stuff like that for practice?
Apparently, AU blocks this page.
Oh no. Okay, I will find another way.
Alright.
Or yeah, you can use it yourself. But say at me.
Yeah, I still lost it 200
Inut. Inut. That's my login for everything. For just so at the time unique, and then I almost can get it for every wall. And then you can leave any comment.
Thank you, Dr. Tim.
Maybe I'll just leave it.